Hey guys, in this video we'll start looking at functions in SQL and design our own scalar valued function. In a nutshell, a function gives us a construct through which we can execute potentially complex code using a simple line of code. Examples of functions that we've looked at before would be like our aggregate functions, max, min, sum, count, etc. But there are dozens of functions in SQL, and in this video we're going to be looking at some of them. Now let's start off with one that we're familiar with. So in a new query window, I'm going to do my usual use school statement, and then in the next line I'm going to do a select statement. Now, what if I wanted to select the highest grade that has been awarded to any student in the enrollments table? Recall that in our school DB, when we look, we have an enrollments table which has a few columns, one of which is the grade. So we want the highest grade that is currently inside that column. So what we would do is actually use one of our aggregate functions in the form of max, pass in the value grade, and then say from enrollments. This would then, when executed, give us the highest grade that is found in the entire table. Notice we didn't use a group by. We're not aggregating our rows or records in order to find anything. We're just looking in and finding the max. In the same way, we can look in and find the minimum. These are examples of functions. So max, min, they're all functions. We have the function name, and then inside of the braces, we have the value that it requires in order to fill its operation. Another example of a function would be getDate. So if I wanted the exact timestamp of my running a query, then I can say select getDate, open and close brace, and when I execute that, I will see that I get the date and time of when I executed the query down to the millisecond. Now, the difference between getDate and the max and min and other aggregate functions is that while they return different types of values. So this is a date time value, whereas max and min return a numeric value, but also getDate doesn't require me to pass in a parameter. If you recall, when I typed in max and open brace, I needed to provide some value that it would use to do its computations. Now, in the context of the date and the time, we can use another function in the form of year, which takes one parameter. So if I wanted the year, having gotten the date, I just wanted the year value for the date, then I can use another function called year and pass in that value as the parameter. So I typed in year, open brace, and then you see that the management studio is letting me know that it requires some date time to be passed in, and it returns an integer value. So when I enclose the getDate, which is returning a date time value inside of the year parameter list, then the year is going to look at the date that is passed in and just return an integer value that represents the year value in that date time. So when I execute, I only get back 2019. Now, moving on from these examples, we can always see the list or a good list of what SQL has to offer us in terms of functions by going into the database and going into the programmability folder, then expanding our functions folder, and then once more expanding our system functions folder. Inside system functions, we see all the different categories of functions that are built into SQL for us. And I'm going to take a look at the string functions. So inside of string functions, you notice that you have one for difference, you have one for length. And if you hover over each one, it kind of tells you what this function is used for. At any rate, you get enough information. If you continue to expand, you see the parameters that are required in order to use this function. You see that it requires at least a varchar expression, an integer expression, and it returns a varchar or nvarchar. Right? So you can always get some information on the types of functions that you need to help manipulate the presentation of your data. Now, there may come a time when you need your own function to return something maybe more table specific and less generic like these system functions, and then that is where we have to start defining our own scalar valued function. Now let us say that at any given time we wanted to call a function that would actually return the highest grade in the class. We did it earlier. We wrote a query, and what we want to do is turn that query statement into a function so that when we call that function, it executes the query unknown to us but returns the appropriate value. So what we need to do is under functions, we go to scalar valued functions, we right click, and then we go ahead and click scalar valued functions, or in some interfaces you may see new, but anyone you see, or you can right click functions and then go to new, and then you select scalar valued function. They will both lead to the same place. Now, having done that, you're given a query window, and it looks complicated, far more complicated than what we've been looking at. But if you take a good look, you notice that it's really not that. It's really simple. Anything that is green or has 2 dashes at the start of the line, that's a comment, and they're really just guides to tell you what to do where. So we can look at it and we see that it's really just generating the template for the create statement that is used to create a function. So we just need to go through and basically replace anything inside of the angle brackets with our own data. So for author name, it's always a good practice to comment your code to say who wrote it, when was it written, and what exactly this function is about to do. Now, when we get to the actual syntax, we see that we have the syntax create, the keyword function, and then angle brackets. And in the angle brackets, they're suggesting that we should specify a function name. So I can replace everything inside this function name, and I'm going to say get highest grade. So this is the name of our function. So once again, we have functions that have names like year and get date. Well, we're defining our own that is going to say get highest grade. Next, we want to start adding parameters. Now, the guideline for a parameter is that we use an @ sign, give it a name, and then a data type. Once again, we're simply replacing anything that has angle brackets around it. So I'm going to go ahead and replace this open and close angle bracket block of text with the name of a parameter. And well, if I'm getting the highest grade from a table, I really don't need a parameter because I'm getting the highest grade in the table. So just like we saw here with getDate didn't require a parameter in order to carry out its duty. So given our context, we don't need a parameter to carry out our duty. So since we don't need a parameter, we actually have to remove that block of text to say, create the function with that name with no parameters required. And then we move on to tell the return type. So the return type is the type of data it's expected to return. So once again, getDate returns a date time, however, year returns an integer. If we're getting the highest grade, then our return type would be, I believe, decimal, based on the fact that the data type for the grade is decimal. And I can always just go back and validate that by expanding the tables, and it is actually float, not decimal. So I'll use float. So the value that our function get highest grade is about to return is a float data type. And then the code continues where it says as, then begin, and then in between the begin and the end keywords, we will actually do some work. So the first thing we want to do is declare a variable for the return type. Now, a variable is like a temporary storage. We create a variable, we give it a value, and then we can use that variable to track this value or manipulate this value into whatever we want and actually store it for the period that we need it. So in this case, we need to define a return value that will be prone to change later on, but at the end of the day, it will be returned, and that is the value that we'll get back from our function. So our declare statement requires that we give our variable a name and then a data type. So once again, the naming convention for any variable or parameter is that it starts with an @ sign and we give it a name. So I'm going to give this one @sign grade, and then the return variable has to match the return type of the function. So that means that this variable needs to be a float, because then it's going to store a float value and it is going to be returned. So it has to be a float value to match back what the function data type or return data type is. Then we go on to assign a value to this variable based on the output of some query. So the next statement goes on to say add the SQL statements to compute the return value here. So I'm just going to remove, once again, everything inside the angle bracket. And then I'm going to start off by writing the SQL statement, and then I'll show you how you actually go about assigning the value. Now, since I only want the grade from enrollment, then I only need to select grade as a column, and then it's coming from enrollments. But then I need to get a bit more creative because I did say the highest grade. So like we just saw, we actually would say max grade from enrollments. So selecting max grade from enrollments will actually look in the enrollments table once again and return the highest grade. So since this column or this function will give us the highest grade, we need to be able to assign whatever value comes back as this return value from max grade here into our @grade variable. And the way to do that is to say select, and then we say the variable is equal to the column that is going to store the value that we need to return. So once again, we say select variable is equal to column or function return type, whatever it is that is bringing back the value from our select statement. We do this assignment inside of the select statement, and then the select statement goes on to say from elements. And if we were filtering, we would put on the where and the group by and all these things. But the fact is, whatever statement we're writing for our scalar function should only return one value that can be assigned to our return variable that was declared inside of our function. Once we've done that declaration, once we've put that SQL statement together and done this assignment, then the last step is to return that variable. So the variable is @sign grade, so we're returning @sign grade. So once again, we create a function, give it a name, we define the parameters. If there are none, we make this area blank. Notice this is a comment, so it has no bearing whether it's there or not. We define the return type of the function, and then within the beginning and the end, we do whatever computations or statements are necessary to get our value to be returned. So we need to declare a return variable, give it a data type, execute some SQL query that is going to go and calculate or in whatever way fetch the value that we're desirous of returning. Then we're going to assign it to our variable. So we say select variable is equal to whatever column or construct is going to be returning that value. And then we go ahead and return that return variable. Having done all of that, we now execute. So remember that all of this was really just one big create function statement. So nothing has been done until we execute. And once we do that and we see that all commands were run successfully, then we can go back to our functions folder, drill down into our scalar valued functions folder, and then we will see that our function is now accessible to us. Now, if we wanted to make an adjustment to this function, then we would have to change the create to alter, and then make whatever changes and then execute, and it would update the function according to whatever changes we've made. However, I'm satisfied with the function as it is, and then I need to test it out. So I want to see if my function will return 100, which based on the query I wrote last time was the highest grade in our database table. So I go back to my query window and I set the context of school. And then what I'm going to do is select and then specify my function, highest, get highest grade. And then because it's a function, I need my braces. And notice I only open and close because we didn't define it to require any parameters. Now, if I execute this, I'll get an error because it will say it's not a recognized built-in function name. And for whatever reason, SQL requires or recommends that we put on that DBO dot when we're calling our own function. So DBO dot and then our function name will solve that. And when I execute, we see that it is returning one value, and that is 100. If I wanted to define another one to get the lowest grade, then I would do the same thing. I would click on scalar value functions, go ahead into the edit view and make all the changes required to get the lowest grade. So that is my challenge to you. Rewrite that query to get the lowest grade and get the number of enrollments, and just, go crazy, get some practice in with the functions. Now I'm thinking of a scenario where I probably would want to get something else a bit more unique. And let's say I wanted to get the course name by ID. So if we go into the courses table and take a look at the data, we see that we have about 11 courses, and they all have titles, the number of credits, and the course code. But I want a function that when I pass in a value, I get back just the title. Of course, we know that if I wanted to see that, I would have to say where, and then say ID is equal to, and then maybe say 5, and then execute this query. And I'm sorry, I put it's course ID, not ID. And then when I execute this query, I get back .NET. So all I want is the title when the function is provided the ID value. So I'm going to go ahead and create a new scalar valued function. And it's going to bring back the same template that we just went through. And then the changes we make are going to be pretty similar. So the function is going to be called get course by ID, or maybe I should be more explicit, get course name or title by ID. Get course title by ID. So you always want to be as descriptive as possible in your function name so that anybody who comes along can look at the function and say, oh, yes, I know what that does. So we're getting the course title by ID. And if we're getting it by ID, that means that we need to provide a way for somebody to give us an ID so that we can know exactly which title we need to return. And so in this scenario, we need a parameter, most definitely. So I'm going to modify this, the angle brackets inside, and I'm going to start off with the one that says define the param name. So I'm going to say param name would be course ID. So I say @ and then give it a name. And that's the name of the parameter. And then I need to specify the data type. And if I'm getting it by ID and IDs are usually integer, then that means the data type of the parameter needs to be integer, because I need to specify that you need to pass in an integer that will act as my lookup ID when I'm executing my query. Now that we've gone through the parameters, the next thing is the return type. So if I'm returning the title of the course, that's a word, then my return type can't be in this time. It has to be nvarchar. So I'm going to say nvarchar, and I don't know the length of a course, so I'm just going to say 50. Well, maybe we can actually just say nvarchar without any specific size, and that would kind of be more elastic to whatever length string is returned. So after defining the function, the name, the parameters, and the return type, we go on to the begin. And then in this section, we declare our return variable. So I'm going to remove this angle bracket block of code and call this title. And I'm going to give it the data type, nvarchar. Next, I need to specify the select statement. So I'm actually just going to write the query first, and then we do the assignment. So I'm going to select title from courses, and then of course, selecting title from courses. And if I run that query over in another query window, if I just say select title from the courses table, then that is what our data set looks like. We get 11 titles. So that's not adequate because we really only need one based on the ID that's provided. And the only way to filter would be to say where the course ID is equal to some value. In this case, if I say 1, we get back HTML. But then we won't always know this value. We want to allow the user to provide this value, which is why we gave them the parameter. So that means if I'm about to make sure that we're finding the course that is corresponding to the ID that's provided, then we need to say where our column course ID is equal to the value that the parameter has. So in my function, I'm going to say select title from courses and then go on and say where the course ID, and the course ID, notice this is not the one with the @ sign, where course ID that belongs to our table courses is equal to @ sign, and then we call in the parameter. So when we do course ID from the table is equal to course @ sign course ID, we're saying where the course ID in the table is equal to whatever value this parameter has. So now that we can feel satisfied that this query would bring back what we want, we can now do the assignment where we're going to assign the title from the table to our return variable that we declared earlier. So I'm just going to say select @ sign and my return variable. And note, we don't have to call them title. We don't have to give them the exact names. As a matter of fact, I tend to prefer not using the same names because to me it's less confusing. So I could have actually just called this name. So I'm going to call this name. So my return variable is name. So I'm going to assign the title value coming from my courses table in the database to my name variable. So I'm going to say select @ sign name is equal to title. And there you see the red lines go away because now it feels satisfied that we're assigning the value to our return variable. And then at the end of it all, we want to return whatever value came back inside of this assignment. Now that we've done this query and we feel satisfied, or this query to create the function, we can execute to actually create the function. And then we can validate that it was created by, once again, going into our database, going to programmability functions, scalar valid functions. And if you're already here, you can always just refresh and then you'll see your new object appear, get course title by ID. If you expand it, it will show you the parameter listing and let you know what is expected of you. So if I go back to my experimental query window where, right, so this is where we are, and then I say select, and then remember we need the DBO, and then I'm selecting, let me just make sure I get the name right, so I can actually just drag and drop from the Object Explorer over to the query window, and it will just generate that code for me so I can avoid spelling errors. And then I try and execute this statement. It won't work because it will tell me that it could not be bound. In other words, it's saying that it's a function I need to put on my braces. And then if I try to run it again, it will not work because then it's going to say I don't have enough arguments or parameters supplied for the function to work. So I need to supply a parameter. And remember that in the definition, we said that we need a parameter of type int. So I'm going to pass in a value and I'm going to say 1. And then we execute. All right, and there it worked. I'm not sure what that error was about. Could not find store procedure S, but there it worked. And okay, so we see that we have a little error because we made a miscalculation with the size of the nvarchar. We only said nvarchar, not nvarchar 50. So it's literally just returning one value because it defaulted to 1. So we need to modify our function. So we go back to our function, and let's say maybe we closed it and we went on with our ways. We can always just right click the function in the Object Explorer and click modify, and it will automatically launch that alter function code that I mentioned earlier. So we're now back in the same query and we need to alter the function. So what I'm going to do is I'm going to say that it returns nvarchar 50 and that our variable to be returned is also nvarchar 50. Because even if I set the return type to nvarchar 50, it would still be truncating if I didn't set the return variable, to also be nvarchar 50. So you want to make sure that the return variable type matches the return type as much as possible. All right. And so we can execute this query because it was really just a query to alter the function. We made our changes and we are satisfied. We execute and then that's successful. So when we go back to our query window, let me just close some of these windows here. We go back to our query window and we execute this function once again. Then I see the full name or title of the course coming back called HTML. If I change this value, we had 11 courses, so course number 11, and then I execute again. It goes in, it looks up on the value that was passed in, and we get back artificial intelligence. If I looked up on 110, and then I don't expect anything to come back, all I get is a null because there's no course in the database with the ID 110. And that's it for scalar valued functions. Pretty simple concept. We can just always create these functions to help us, write queries more quickly or execute queries on the fly in more complex queries without having to complicate that actual query. We can just create a function, write the query that we wish to do in the background, and then call the function anytime we need that particular value. So the next topic would be on table valued functions, and that gets a bit more exciting, but I advise you, or I'm encouraging you to actually do some practice on this one, create some functions within the context of this or any other database that you may have working with, and just explore all the possibilities.